Before that, let me tell you what are the different parts of a blast furnace. You have seen the construction and accessories. Can you tell me what are the different parts of a blast furnace? Can you tell me what are the different parts of a blast furnace? Hello?
Ma'am, the throat, the bell system, the throat, stack, belly, Bosch, and
what are the different parts of a blast furnace? Are you able to hear me? Hello? Are you able to hear me?
Yes, ma'am.
Now you tell me what are the different parts of a blast furnace? Different parts of a blast furnace. Suppose I say, what are the reactions taking place in the blast furnace? Can you tell me in which part what reactions are taking place? Hello?
Melting will be done in Bosch, ma'am.
Melting.
Melting is done in Bosch part. Reduction will be done in stack region. Complete melting reduction will be done in stack region and
near the cure part, gasification reaction will take place, ma'am.
That is
at the top of the stack, we'll have the reduction of the higher oxides, ma'am, and deposition of carbon, ma'am. In the stack region, we will be having the gasification reaction and the indirect reduction of iron oxide, ma'am. And in the combustion region, we will be having direct reduction of iron oxide and reduction of gangue, ma'am, into slag.
Then after the tour, what is there at the bottom?
Hearth, ma'am.
Hearth. Okay. So let me tell you, the blast furnace parts are throat region, throat in the top, throat. Then the next portion is the stack region. The next is a Bosch parallel. Then the combustion zone. Then the hearth. Normally the parts are throat, stack, Bosch, and the hearth region. So in the throat region, the temperature is very less, 100 to 200. So only drying and preheating of the charge takes place. In the stack region, the temperature gradually increases from top to bottom. The reduction starts, reduction of iron ore and gaseous reduction, indirect reduction. So hematite is getting reduced to magnetite, magnetite to wustite, wustite to iron. Carbon deposition reaction is taking place, dissociation of limestone is taking place. In the Bosch region, the temperature is quite high, so fusion starts, not completely melting. Fusion, melting starts. Direct reduction takes place. Reduction of metalloids takes place. Desulfurization starts. Tour region, combustion of the coke occurs. In the hearth region, already reduction is over in the top stack region, iron. So while it is coming into the hearth region, slowly from solid to liquid it is transforming, and it takes the silicon, sulfur, phosphates from the Bosch region, picks up all this and settles in the hearth. That is why in the hearth we get pig iron, and on top of the pig iron it is slag. Okay. So at the top charging system, this slide, if you are able to see, these are the top charging systems. How they are charged. So we have charging systems. Top charging is bell system of charging, and now this is a small bell, this is the big bell. It's a large bell. It is written here large, it is written here small bell. This figure you see. So this is the large bell hopper bell. This is a small bell hopper. Okay, small bell, large bell hopper, small bell hopper. all this. That means two bell system. This is a two bell system of charging from the top. Raw material from the raw material yard to the blast furnace, that transportation can be done with a conveyor belts or bucket system of charging or skip system of charging. I will show you the figures later on. So the top charging in the blast furnace, whatever we are charging, old furnaces, blast furnaces, they used to use bell system of charging, two bell system. Nowadays they are going for bell-less system of charging. Vizag steel plant follows bell-less system of charging. That is, there are no bells, Polworth bell-less system of charging. That we can study, that we will come to know when you are studying about modern developments of the blast furnace. So raw material from the raw material storage yard to the blast furnace can be conveyed through conveyor belt or skip or bucket system. So this is a skip bucket system of charging. So this is a skip. You are seeing the gray color arrow is there. That is a skip bucket. This is a skip bucket. The bucket is discharging the raw material into the small bell. Okay, small bell hopper. This big bell is closed. You see this big bell, large bell and the large bell hopper, there is no gap here. So it is closed. Next, after charging, the small bell is lowered. You are able to see the small bell is lowered. You see the cursor. So this is a dark region, is a very dark black bell. There's a gap between this gray color hopper and the bell. So the material is falling into the big bell. You are able to see? Hello? You are able to identify? Okay.
Yes, ma'am.
Yes, ma'am.
You see my cursor. Okay. Here the big bell is closed. If it is open, what will happen? This dark cone, they will have a gap between this wall. This is a hopper. This is the bell. This is the bell. This is the hopper. So the material is charged into the small bell. Big bell is closed. The small bell is open. Now after the material falls into the big bell, the small bell is raised, and the small bell, when it is raised, it will close the hopper. So the material is in the big bell. The big bell is lowered. So the material is falling into the into the blast furnace. The material is falling into the blast furnace. This is the throat region of the furnace. So after the material is discharged from the big bell is also raised and it closes. So this way the top is closed completely. Then operation takes place in the blast furnace. So you have the bucket system of charge skip system. It charges the material in the small bell. Then the small bell is lowered. It is raised, it is closed. Then the big bell is lowered. The material falls into the blast furnace. Then the big bell is raised up. So that the operation takes. Here from at the sides, last class I showed you the uptakes and downtakes. So you have 4 uptakes. It is circular in cross section. So 4 uptakes will be there. Uptake means the gases are going away from there. When the gases are going, the gases will go up till here and they will go from here. You will have an uptake, 4 uptakes. The gases will go from the uptake to the downtake to the gas cleaning system. So this is the system of charging. So what happens? Frequently, they have to raise the bell, lower the bell. So the small bell is raised, the small bell is lowered, the big bell is raised, the big bell is lowered like that. So there will be a lot of wear and tear of the bells. That's why nowadays they are going for bell-less system of charging. And while lowering and raising, the gases may go this way. So what happened? They are unable to create a high top pressure. If we have a high top pressure, that is what happening. Blast is entering into the blast furnace, hot air. Blast is hot air is entering into the blast furnace at the tour level at such a high velocity, and it is staying in the furnace for a few seconds and is let off to the gas cleaning system, followed into the blast furnace stove to recover the potential heat. If we can create a pressure at the top, that is known as high top pressure. Suppose I say the pressure of the gas which is entering into the blast furnace is 3 atmosphere, and here it is 0. That means there is no pressure at the top which is going on. Suppose we are able to create a pressure at the top about 1 to 1.5 atmosphere, that is a back pressure. That is known as high top pressure. What is the advantage of creating pressure at the top is we are allowing the gases to stay in the furnace for a longer time. So reduction will take place for a longer time and more complete reduction will take place. That is the idea. So this is only to, this figure is to tell you about, to show you the top charging system. So next comes, once you are seeing the reactions in the blast furnace. So once the pig iron is produced, what are the methods of disposal of pig iron? Pig iron is disposed by casting the liquid metal into pig casting machines to produce a solid pigs for use in foundries. When the pig iron is in the liquid condition, we call it as a hot metal. When it is solidified, we call it as pigs. So solid pigs means pig iron is solidified. Then we call it as pigs. Suppose the pig iron is not cast, it is in the liquid condition, we call it as a hot metal in the blast furnace. For the blast furnace liquid iron, we call it as a hot metal. Nowadays, what is happening? The steel, iron making and steel making plants are synchronized in such a way that once a pig iron is produced, it can be directly sent to the steel melting shop for production of steel. Olden days, the blast furnace and the steel making shop was not synchronized. That means that once the pig iron was coming out from the blast furnace, the steel making shop was not ready, or they had to transfer it. So the steel making shop was not ready. They cannot keep the pig iron in the liquid condition for a longer time. So they used to cast it and produce the solid pigs, which can be later melted before charging it to the steel melting shop. Now this pig iron, either they can go for the foundry shops for making castings. Foundries and casting, some steel plants will have their own foundries. Some steel plants will have their own foundries. So about 20 to 30% of the pig iron is taken to their foundries and the rest is taken to the steel plant. Or what they do, they will take the pig iron to their own foundries, and later the solid pigs can be sold to the other foundry shops nearby, outside the steel plant. You understood? I will repeat again. Pig iron is disposal is, one goes to the steel making shop for melting, one goes to their own foundries, or it may go to the foundries outside the steel plant. For example, if you have a hospital, what is the nearest, what are the shops which come nearby a hospital mostly?
Pharmacy shops.
Very good. So that similarly, like that, whenever we have steel plants, nearby foundry shops come into picture, because they will buy the pig iron from this one, and they will remelt it and they will produce steel or alloy steels, like that. Small shops will be there. That is how it is disposal. Whenever blast furnace and steel making shop are synchronized, the pig iron is taken to the steel melting shop, because what is the raw material for steel? Pig iron. What is steel? It is an alloy of iron and carbon, with carbon 2%. What is the carbon content in pig iron?
4%.
So what is that is a source of raw material. So whenever we are charging pig iron to steel melting shop, it should be molten pig iron, LD converter, decimer converter. But electrical arc furnace and open hearth furnace can take solid material. So depending upon the requirement, this is a pig iron, or the pig iron can go to the pig casting machines. So disposal of the slag, apart from the pig iron, the other one is slag, which is coming out from, which are tapping out from the tap holes. Slag is carried into the ladles to the slag dumping yard, where it is tipped as a waste material. Alternatively, slag granules are produced in a granulation plant, where molten steel is poured in turbulent water and granules are produced. The slag granules are used as a construction material. For construction material, when we use cement, what does cement consist of?
Silica, ma'am.
Silica and main thing,
Calcium.
calcium. So in the blast furnace slag, also you have some lime and silica, because you are using flux, which is calcium carbonate, and silicon is an impurity from the raw material. So there also the slag consists of silica and lime. So it can be, the slag can be used as a cement. So the cement can be used in construction industries, in road making industries, like that. Otherwise, if you leave the slag granules like that as a waste, lot of environmental pollution will be there, because this is a waste. instead of leaving it as a waste product, which will pile up and require a dumping space large amount, you can use it as a blast furnace slag cement. Or what is that? This blast furnace slag can be used as a glass, because glass also contains silica. So it can be used as a glass wool. These are the granules, small granules. How they are able to get granules? Slag is molten product, so when it is coming out, when the molten metal is coming out, suppose they spray water or any other fluid, the molten metal when it is falling like this, if you spray some fluid, the molten metal will break into droplets. So that is how small granules are formed. These granules can be used because they are a source of lime and silica. Similarly, they can produce glass wool. Have you seen wool? Whenever you wear woolen clothes in the winter, you wear woolen clothes in the winter, so you can see wool is very soft, no? So similarly, when they are producing slag wool, silica, etc. is an insulator. So slag wool is an insulator which can be used as a furnace lining. I told you in any furnaces, what is the purpose of a furnace? What is the purpose of a furnace?
Smelting and reduction.
Furnace. So, that's smelting. What is the requirement is, because smelting is required, first of all, heating furnaces, melting furnaces, reduction furnaces, refining furnaces. Furnaces can be, when you have studied principles of extractive metallurgy, you might have seen the different furnaces, melting furnaces, smelting furnaces, refining furnaces, just preheating furnaces, like that. Or what happened if you have studied heat treatment is over for you, phase transformation heat treatment, subject is over. You studied heat treatment. So there are heat treatment furnaces, you must have studied annealing furnaces, salt bath furnaces, moving furnaces, like that, no? Continuous furnaces, batch furnaces, like that. So when furnaces are used for heating or melting, we want the heat to be inside the furnace, the heat should not be lost outside. So what they do, the furnace shell is a steel shell. Inside they line it with refractory bricks. So this refractory bricks will help to see that the heat is preserved inside the furnace. Whenever a furnace lining is given with a refractory brick, the capacity of the furnace may become lesser. It is lesser. But if we go for, suppose this is the furnace, roughly I'm telling you, this much amount will be the lining. All this is the refractory lining. So this is where you are heating the stock. Instead of having this refractory lining, if you can use glass wool, then the glass wool thickness only this much. So what is happening? The capacity of the furnace is more, and the glass wool which you are using as an insulator, rather than the refractory as an insulator, the furnace will be lighter. The furnaces will be lighter. So that way also you can use that is the usage of this slag. Slag granules are there. I was telling you about the charging system. So what is the charging of the raw material into the blast furnace right from the storage yard. So they will have a raw material storage yard. From there the raw materials are transported to the blast furnace. So how the raw material is transported from the blast furnace, from the raw material to the blast furnace, this is a conveyor belt. You are seeing this rubber belt. This looks like actual rubber, this hard rubber. So this you are seeing, no? You are able to see this. This is a rubber conveyor, belt conveyor. This is a belt conveyor, huge belt. These are the rollers. You are able to see the roller? Hello?
Yes, ma'am. Yes,
So
ma'am.
these are.
Yes, ma'am. Yes, ma'am.
This side also this side also rollers. This side also rollers are there. So that what will happen? This belt is not flat. If it is very flat, the material will fall from the sides. So the rollers are at an angle. So the belt will form some depression. So the material which falls on the belt, it is conveyed to the blast furnace. From the top of the blast furnace, they use belt system of charging. From the raw material to the blast furnace, this is the conveyor belt in which raw materials are charged. In other figure, this is a skip system of charging. So they are charging the raw material. These are the skip. I'll show you the next figure. You are seeing two skips. This is one skip. This is the other skip. At the bottom, there are rollers will be there. The skip will move to the top and discharge the raw material inside the furnace. See this one. This is the skip. Last one is a skip car. You are seeing the rollers here. These rollers. So this will turn like this. So this is the hole through which they will fix it. So at an angle, it will be moving. At an angle, it will be going up. So this is at flat angle. So the raw material will be charged inside it. These are the rollers. This is a track. This is a track. So one skip, when it is discharging the raw material inside the furnace, another skip will be at the bottom where raw material is charged. So when this is charged, this is coming out, this will be going up. So they will be having two skips. One skip will be charging into the furnace. One skip is at the bottom, is getting ready to be charged with the raw material. Ready to charge with the raw. This is a skip car. Okay. So apart from this, they also can use bucket system of charging. What if they use bucket system of charging? One bucket will be charging. By the time it is coming down, the new bucket which is charged is getting ready here will be going up. So continuously, one will be coming down, the other one will be going. The one which is going is taking the raw material. The one which is coming down is already the raw material is charged. It is getting ready with the new raw material to go up. So in that way, you can use skip system of charging or buckets, conveyor belt system of charging. Now you see this is a conveyor belt system of charging. This is the skip system of charging. What is the essential, which one will occupy large space? Conveyor belt or skip system of charging will occupy large space? Hello?
Conveyor belt, ma'am.
Very good. Why? Very good. Why?
It has to gain the height, no, ma'am. So it cannot be in a single this one.
Suppose I put at this height conveyor belt, what is the problem?
Ma'am, the granules may roll back, ma'am. The bottom.
What will happen? That is, the material will fall because conveyor belt is flat. So it requires what do you say, less angle. This steep angle is no problem because you have a container here. But the belt conveyor means what? There is no conveyor. So what happens? This should be at a small angle. Small angle means it will occupy a large space. Large distance will be there. Similarly, what will happen? This belt will be having different material, made of material, different materials. So magnetic belt is there. So it will take, if you have magnets at the top, or like somewhere here, what will happen? Any magnetic impurities or magnetic concentrate, etc., it can remove big ore particles, etc. Only the right size material is going from the belt. So skip system or bucket system of charging is the term. This is a ladle. So it is actually concave surface ladle. It is at a flat. They are discharging the hot metal. So this ladle is used for removing the metal from the furnace into the ladle. From the ladle, it will go to a, from the ladle, it will go to the steel plant. But the ladle will be having about 800 to 1000 tons capacity. Suppose you can remove the hot metal in 2 to 3 ladles. So what they do, they will take the ladle full of material, and from the ladle, it will go to the mixer. From the mixer, and again, it will go to the ladle. From the ladle, it will go to the steel plant. From the ladle, it will go to the steel plant. So here, this ladle is also a steel shell lined inside with refractory bricks. So it is a container to take the hot metal. It is a container to charge the hot metal into the steel plant. It is a container where metallurgical operations can be done. That is a function of a ladle. A ladle is simply a storage vessel. A ladle can be a storage vessel plus some metallurgical operations can be done. A ladle is a vessel, it is a transporting vessel for the hot metal from the blast furnace to the steel plant. Now I was telling you about hot metal disposal. Pig iron can be taken to the foundries for casting. It can be taken to the steel plant. If they are casting it, this is a pig casting machine. So this is the ladle. This is the ladle. It is slightly tilted, so the hot metal is falling into this pig casting machines. These pig casting machines are rectangular in cross section. So the hot metal, when it comes from the pig casting machine, the machine moves in the rollers up till here. By the time this roller comes here, solidification is over. So the pigs are removed, and they can resolidify it and they can charge it into the blast furnace. These are the torpedo ladles. They are very higher in capacity. This is a smaller ladle. This ladle, this figure, this ladle is smaller in capacity. 2 to 3 castings of the ladles will fill one torpedo ladle. This torpedo ladle will be taken to the steel plant. Again, from the torpedo ladle to the ordinary ladles, from the ladle into the steel making furnace, like that. That is how the hot metal is transferred, or steel can be transferred one part to the other. In the olden days, when the blast furnace was of smaller capacity, and the steel plant, they used to charge solid pigs. That means the steel plant need not be ready. They used to take the pig iron, some to the foundry, and some they used to cast it by pit casting. Pit casting. Suppose I say, so this is the furnace, this part is the furnace. So from here, it is a ladle. So the pig iron falls here, is taken into this ladle. So here what will happen, this ground will be there. So this ground will be having narrow channels. These are the pits. So from the ladle, the hot metal was put in the pits, and they used to wait for the solidification to take place. Then the pig iron was removed and taken to the steel plant. Pit means what? You are digging a pit in the ground level. So this is the ground level. They used to dig this pit and they used to line it with refractory bricks, or the sand was very hard, it was not loose. So hot metal is taken into the ladle, from the ladle into this pits. This is the pit system of casting. Pit. What is the disadvantage of pit casting compared to this one? Pit casting machine. What is that?
Ladle moved, ma'am.
Tell me what?
Ladle has to be moved, ma'am, in pit casting, which is difficult.
What else?
Ma'am, the temperature of the slag is maintained in the hot ladle, but not in the pit casting.
Slag is మాట్లాడదాం, hot metal మాట్లాడదాం.
Temperature will vary, ma'am, in pit molding, pit casting.
How?
Casting.
You are very near to the answer. Very good. How?
Ma'am, the ground will absorb the temperature, ma'am. There will be heat loss.
Okay, very good. One thing then.
Ma'am, removal of solidified pig iron is easy, ma'am. In
where?
This
Pit or pig? Pig. Is it pig?
In pig it is easy, ma'am.
Very good. Very good. Why? Both answers are good. Why? Next question. Why?
Because in pit casting, the solidification is done in the sand mold, ma'am. And
sand and ground
mold should be ground, yeah. The ground that should be broken. That should be broken for the removal of that casting inside.
Which one should be broken? This ground level andi. Pit ante meeru hole dig chesaru ante. Bhumi tavver. And you see that sand is very hard. You can also have a refractory lining. So after solidification only you can remove that. No, you are removing the pig after solidification. Antena? What is the solidification temperature? Room temperature. But still, room temperature, the temperature will not be 0. It will have some heat. You hot water glass or in a container, if you are heating the water, after once you stop the stove, immediately the water will not come to 0. But the stove is offed. But you cannot catch the vessel, it is very hot. So similarly, when you are putting after casting, it is still hot. So the person has to wait until it is completely cool, then only he can go down, because there will be some steps here. You put exactly steps ఉంటాయి. Suppose మీ పాతకాలంలో వెల్స్ మీరు చూస్తే కొన్ని స్టెప్స్ ఉంటాయి, చూసారు ఎప్పుడైనా? ఆ వెల్ లోపలికి కిందకి దిగాలంటే సైడ్ కి స్టెప్స్ ఉంటాయి, వాడు అలా దిగుతాడు లోపలికి. ఎప్పుడైనా చూసారా ఊర్లో?
Yes, ma'am.
Alright. So what happened? So the person has to go into the pit. When he is able to go, when the temperature is very normal. So after casting, he has to wait until the temperature is very 0. Then he can go down the pit. He will take the pig and come out. First negative point. Inko negative point edana cheppandi. Pit casting ki pig casting.
Ma'am, the final casting shape can be any shape in pig casting, but not in pit casting, ma'am. It's difficult to get the shape.
Suppose I will give you a hint. Now, what I told you, pit casting was done in olden days. First point I told, if you remember. In the olden days, second part, what I told you, the blast furnace need not be synchronized with the steel making. That means steel making shop need not be ready. Once the blast furnace figure is coming out, it need not be ready. That means what? You can charge a solid pig. Okay, you understood now? Confused about what is the key point? Pig iron directly melting shop we can go. When the steel making shop and the blast furnace is synchronized, this pig iron can be directly taken to the melting shop. When the steel melting shop is not synchronized with the blast furnace, or when the steel making shop can take solid pigs, then we can solidify the pig iron, then we can again remelt it into the steel making shop for melting. And in steel melting shop, some furnaces can take solid pigs. For example, open earth furnace, electrical arc steel making furnaces, you can charge solid pigs. But in LD converter, now the LD converter or Bessemer converter, you cannot charge solid pigs. You have to charge only pig iron. So if solid pigs are there, again they have to be remelted in a melting shop, then only charged. You understood up till here? You got the point? So now, when I tell you the spit casting was done in the olden days, what was the first point I told you? When the capacity of the furnace was less, when the amount of less pig iron was produced, they used to go for the spit casting. Suppose the capacity of the furnace is very large. Now, instead of this, you are having a very large furnace. So the production of the pig iron quantity is also very good, very large. So what is the problem with this spit casting? What will be the problem?
Yes, ma'am. Because of the continuous coming of the hot metal from the blast furnace, it has to be synchronized with the steel plant, ma'am. Because again solidification, again remelting, it will cost the money, ma'am.
Okay, that is with steel making. Ikkada answer cheppandi. Ee answer lo what is this question I asked you? When the blast furnace capacity was less, in the olden days they used to go for the spit casting. Now when I say the blast furnace is increased and the capacity of the pig iron, pig iron cast, the capacity, the vessel capacity is more, because lot amount of pig iron is coming out. What is the problem with pit casting?
We have to dig more, ma'am.
Very good. So we have to dig
More.
So what is the problem with digging more?
Place consumption will be more.
Very good. What is the next problem? Space consumption. Then next problem.
Solution, ma'am.
Refractory lining.
Very good. Which one?
Refractories more we have to use, ma'am.
Inka?
Ma'am, the ground will be affected, ma'am. It cannot be again
Ma'am,
pollution,
Very
right?
good. Very good. Very good. Very good. Very good. Nice. What happened is space will become more. Okay. Because when the space becomes more, we are not able to use that pit, because once it is a pit, we cannot use it for any other purpose. First point. And other one is, whatever you are charging in the first pit, when the pits are more, the temperature of the hot metal in the ladle will fall. No? You are understood the pit. Suppose number of pits are, suppose 5 pits are there. The ladle, by the charging into the 5 pits, okay. But if the pits are 10, 20, 30, the hot metal in the ladle will not stay in the liquid condition for a longer time. So the hot metal may solidify. Once it solidifies in the ladle, you cannot cast it in the pit. That is a problem. So first problem, very good students. It takes large amount of space. So large amount of unnecessary space is wasted because of this pits. So that is why the next development was pig cast. This pig casting machine means what will happen? In a less space, you have this pig casting made of cast iron boxes, rectangular. So once this box comes here, another box is going. It is a continuous belt. So in a less space, even if the ladle capacity is very large, we can go for this one. So the space occupant will be lesser in the pig casting machine, and weighting will be lesser. If it is a pit, you have to wait. It is like that until it is cooler, until it is safer for a person to go down. But it's a pig casting machine, in a less space, we can go for, even if the capacity of the ladle or number of tappings of the ladle, not only capacity, number of tappings are more in the blast furnace because of increase in capacity, this will occupy less space. If it is more, means number of pits are very large, so the liquid metal is falling into the first pit to the last pit. This will not stay solid. It will not stay liquid. Sorry. So it will not stay in the liquid condition. It will solidify. So it is a disadvantage. So that's why pig casting is more advantageous. And because it is better to charge liquid hot metal into the blast furnace. This also was this pig casting also is only for pigs with 20 to 30%. Whatever pig iron they produce, 20 to 30% is cast. The rest is directly taken from the ladle to the torpedo ladle, then again to the ladle, then again to the steel plant for immediate production. That is why blast furnace and iron making, blast furnace iron making and steel plant are synchronized. Otherwise, it is a disadvantage, as the person is saying. You cast it again, you remelt it, then again if you add it, it is not economical. But that was there in the previous olden days, but nowadays because of technology development, LD converter has come into picture. LD converter takes liquid steel. Even you can charge liquid steel in open earth and electrical arc. Previously in the old furnaces, that was the situation. So those are the charging systems, bell system, bellless system, conveyor belt, skip system, and bucket system, and what are the uses of slag and what are the uses of hot metal, and what are the uses of pig iron apart from pig iron, it is used as a raw material for steel, and it is also tell me where it is used, pig iron.
Foundries, ma'am, cast iron production.
Oh, very good, cast iron. From cast iron, what you get? From cast iron, what is that you get? White cast iron. What is that you get from cast iron? Cast iron is very brittle, no? It's greater than 2.5% carbon. It's very, very brittle. What you will do with cast iron? Maybe you can use it as a lathe beds or something, but that also we have to change the cast iron composition and structure. Suppose I say white cast iron is there. White cast iron can be transformed into, what are the other types of cast irons you have studied?
Malleable cast iron.
If you take white cast iron and heat it for 100 hours, malleabilization, you get malleable cast iron. How do you get spheroidal cast iron?
By adding spheroidizing agents.
What are the spheroidizing agents? The name, the actual word.
Silicon.
They add చేస్తారు. ఏ ఫర్నెస్ కనుగుతుందా?
కండిషనరీలో ట్రీట్మెంట్ చేస్తారు మ్యామ్.
So those are known as inoculants. You remember inoculants? So when you add inoculants, you get gray cast iron or spheroidal cast iron, C treatment చేసి ఇవన్నీ వస్తాయి. Okay. So why? Because the carbon can be in the form of spheroid, that is spheroidal cast iron, or ductile gray cast iron, or simply gray cast iron where it is in the form of graphite flakes. So gray cast iron ni malli meer spheroidize cheyalante you have to go for spheroidizing treatment. That spheroidizing treatment is what is that it is you are doing? You have to take this iron and at the lower critical temperature alternatively you have to heat it, cool it, like that. That is you are converting that laminar into spheroids. What is the advantage of spheroid over laminar structure?
Strength, ma'am. Strength of spheroid.
Elaga strength 18 చెప్పండి. సో స్ట్రెంత్ ఎలా పెరుగుతుంది? దేంట్లో స్ట్రెంత్ ఎక్కువ ఉంటుంది? స్టెరాయిడ్స్ లోనా గ్రే కాస్ట్ ఐరన్ లోనా?
స్టెరాయిడ్స్ మ్యామ్.
ఎందుకు?
నాడ్యూల్స్ ఆఫ్
స్ట్రెంత్ దీంట్లో ఉంటుందా? దీంట్లో ఎక్కువ స్ట్రెంత్ దీంట్లో కంటే?
Strength will be more in the laminar, ma'am, because the concentration of the carbon will get concentrated in the spheroidized cast iron.
ఇక్కడ మరి స్పెరోడైజేషన్ వర్డ్ వాడకూడదు.
Yeah, yes, laminar. Carbon is more evenly spread in the laminar iron, ma'am.
Okay. Because why strength increases? Why strength increases? What are the
percentage of carbon increases?
Grain boundary decrease.
ఇంకా మామూలుగా
fine structure, man.
ఇంకా
number of grain boundaries increases.
మీరు డిస్లొకేషన్స్ పాయింట్ ఆఫ్ వ్యూ చెప్పండి. Why strength increases?
Dislocation density increase అయితే స్ట్రెయిన్ హార్డనింగ్ వల్ల స్ట్రెంత్ ఇంక్రీజ్ అవుతుంది.
మరి ఇక్కడ డెన్సిటీ కాకుండా డిస్లొకేషన్ వర్డ్ వాడి చెప్పండి. మీకు హింట్ ఇచ్చాను కదా, డిస్లొకేషన్ అని వర్డ్ హింట్ ఇచ్చాను కదా. సో ఇప్పుడు నాకు చెప్పండి ఇక్కడ ఏమవుతుంది? సో డిస్లొకేషన్ స్మూత్ స్ట్రెంత్ తగ్గుతుందా పెరుగుతుందా? ఇఫ్ ద డిస్లొకేషన్స్ ఆర్ నాట్ మూవింగ్, the strength is more or less?
More, ma'am, more.
At dislocation smooth strength ela ఎక్కువ అవుతుంది.
Ma'am, it results in stacking of the dislocations, ma'am, which in turn increases the resistance.
Stack అయినప్పుడు that means dislocation stack అవ్వాలంటే మూవ్ అవ్వకూడదు కదా. డిస్లొకేషన్స్ స్టాక్ అయిపోవాలంటే ఒక దగ్గర ఉండిపోవాలంటే అది మూవ్ అవ్వకూడదు. అంటే when there is a resistance to movement of dislocations, the strength increases. When there is resistance to movement of dislocations, ఈ అలా మూవ్ అయిపోతుంటే ఏమవుతుందండి? ఈ ఎడ్జ్ డిస్లొకేషన్స్ అలా మూవ్ అయిపోతే ఏమవుతుంది? మీకు ఒక గ్రెయిన్ బౌండరీ అడ్డొస్తే ఏమవుతుంది? ఈ ఎడ్జ్ డిస్లొకేషన్స్ కదా. ఎడ్జ్ డిస్లొకేషన్ ఇలాగైనా సైన్ పెడతారా?
Yes, ma'am. Green hardening. Green hardening.
Strain hardening will be done.
That means deformation ఉందనుకోండి. What are the types of deformation? అంటే మీరు ఇప్పుడు చదువుతున్నారు. What are the types of deformation? Plastic and other one?
Elastic.
Very good. So which one is permanent deformation?
Plastic,
ma'am.
Very good. So మనకి ప్లాస్టిక్ డిఫార్మేషన్ అవుతేనే కదా మనం రిక్వైర్డ్ సైజ్ అండ్ షేప్ చేస్తాం. That means if you want to get a bucket, if you want to get a plate or something, until you do plastic deformation, you cannot get it into the required size and shape. That means you have to take that material to its plastic deformation stage. If you do elastic deformation, what will happen? It will regain its original size and shape. So plastic deformation is can be done by two. What are the two mechanisms for plastic deformation? Plastic deformation occurs by two mechanisms. One, two. Chapter.
Slip and twin, man.
Very good, very good, very good.
Slip
So
and
slip
twinning.
and twinning. So slip twinning there. Then slip and twinning is caused by dash.
Edge dislocation and screw dislocation.
So movement of
Stacking
edge.
fault.
అదే మూవ్మెంట్ ఆఫ్ ఎడ్జ్. సో ఇప్పుడు ఈ ఎడ్జ్ డిస్లొకేషన్స్ మూవ్ అవ్వలేకపోతే మీకు డిస్లొకేషన్స్ మూవ్ అవ్వవు. మీకు డిస్లొకేషన్స్ మూవ్ అవ్వలేకపోతే మీకు స్ట్రెంత్ పెరుగుతుంది. సో మీకు ఇప్పుడు లామినార్ ఉన్న ఫ్లేక్స్ ఉన్నా మీకు డిస్లొకేషన్స్ ఆర్ మూవింగ్ కదా, ఇక్కడ నుంచి మూవ్ అయిపోయి దే మూవ్ ఓవర్ ఏ లాంగ్ డిస్టెన్స్ ఇక్కడ మీకు అడ్డుతుంది. కాకపోతే మీకు ఇంటర్ లామినార్ స్పేసింగ్ తక్కువ ఉంటే స్ట్రెంత్ పెరుగుతుంది. అలాగే ఇది ఫైన్నెస్ ఎక్కువ ఉంటే స్ట్రెంత్ పెరుగుతుంది. What will happen here? మీకు డక్టిలిటీ పెరుగుతుంది బికాస్ ద మూవ్మెంట్ ఈజ్ ఈజియర్. సో స్ట్రెంత్ తగ్గి డక్టిలిటీ పెరుగుతుంది. ఇక్కడ డక్టిలిటీ తక్కువ ఉంటుంది, స్ట్రెంత్ ఎక్కువ ఉంటుంది. మీకు గ్రాఫైట్ ఫ్లేక్స్ అయిన లామినార్ స్ట్రక్చర్ లో డక్టిలిటీ విల్ బి వెరీ లెస్ బికాస్ obstructions to movement of dislocations is more. మీకు ఇక్కడ ఇటు అటు మూవ్ అయిపోతాయి డిస్లొకేషన్స్. సో మీకు obstructions తక్కువ. సో డక్టిలిటీ ఎక్కువ ఉంటుంది, స్ట్రెంత్ తక్కువ ఉంటుంది. ఇక్కడ డక్టిలిటీ తక్కువ ఉంటుంది, స్ట్రెంత్ ఎక్కువ ఉంటుంది. ఇక్కడ మీకు డక్టిలిటీ పెంచాలి అంటే మీరు ఈ డిస్టెన్స్ ఉంది కదా ఇంటర్ లామినార్ స్పేసింగ్, ఇది చేంజ్ చేయాలి. హౌ యూ చేంజ్ ఇట్? ఐసోథర్మల్ ట్రాన్స్ఫర్మేషన్ లో మీకు ఫైన్ స్పేసింగ్, కోర్సర్ స్పేసింగ్ అలాగే వస్తాయి. ఓకే, మరి ఎక్కడి నుంచి ఎక్కడికి వెళ్ళిపోయాము? సరే, కమ్ బ్యాక్ టు దిస్ వన్. So pig iron, when pig iron goes to the steel making shop to get steel, pig iron goes to the foundries, to the cupola to get cast iron. From the cast iron you can go for malleabilization treatment to get malleable cast iron, that is 100 hours heat chest make malleable cast iron వస్తుంది. అదే cast iron if you remelt it and if you add inoculant sodium, cerium etc, you get gray cast iron. Or if you take the pig iron and heat it in a reverberatory furnace, you get wrought iron. Have you heard of wrought iron? There are three types of iron: iron, pig iron, and wrought iron. Wrought iron is the purest form of iron with slag in a mechanical mixture. But that is, like I told in the very first class, any pure metal is very soft, ductile, but it's very soft. That is why wrought iron was very rarely used. Olden days they used to use it as chains, hooks, etc. Nowadays they are using steel. So if I repeat again, the uses of pig iron is for steel. The use of pig iron is for steel, for production of cast irons, and then from cast iron to various types of malleable SG iron, spiral iron, like that. Or it can be taken to the reverberatory furnace to produce wrought iron. But nowadays they are not producing wrought iron. We're coming to the blast furnace operation. Last time I was telling you how. Now you have seen the construction of the blast furnace, the raw materials in the blast furnace. So whenever the furnace is ready, the blast furnace stoves also should be ready, all the equipment. So in the first question which I asked you, what are the parts of a blast furnace? You have to throat, stack, and the bosch and the hearth. And the lining in the refractory lining, refractory coolers in the blast furnace. What are the blast furnace accessories? Blast furnace accessories means apart from blast furnace, what are the other equipment? You require top charging system, you require gas cleaning system, you require blast furnace stove. Apart from the blast furnace stove, blast furnace gas cleaning system, what are the other equipment usually required? In a blast furnace accessories means extra equipment. Apart from the blast furnace, the extra equipment I told you is gas cleaning system, that is dust catcher, scrubber, electrostatic precipitator, and blast furnace stove, and the top charging system, and the raw material transportation system from the raw material yard to the blast furnace. Then you require ladles for tapping out the hot metal. Apart from this, is there anything else you require? Any other equipment?
Maybe sintering outlet.
Okay, sinter pellets raw material. What else? Equipment. I'm talking about equipment. Blast furnace. Other equipment is gas cleaning system. Other equipment is a blast furnace stove. Other equipment is a top charging system. Other equipment is transportation of the raw material from the raw material yard to the blast furnace. So you are getting pig iron and the slag. From the top you are getting the gas. So can you just directly take the hot metal into the steel making shop? Suppose you are given a job at the blast furnace. The pig iron is coming out. Will you directly take the pig iron into the steel making shop, or is there anything you have to do before taking it and charging in the steel making shop?
Mixers.
What?
Mixers.
So are the equipment. లోపల దాని ఏం ప్రాపర్టీస్ మనకి తెలియాలి? What are the properties we should know of the pig iron before charging it into the steel making shop? What are
Percentage of carbon.
Very good. Percentage అంటే percentage of carbon, percentage of silicon, దాని అన్నిటికీ ఒక వర్డ్ వాడతారు. ఏంటది?
Composition of.
Very good. Very good. Very good. So we require composition analyzers. Correct? Analysis of composition analyzers. Now ఇంకేం కావాలి మనకి? ఇంకే ప్రాపర్టీ టెస్ట్ తెలియాలి?
Viscosity.
Viscosity. Okay, then అంటే viscosity ఇంకొక వర్డ్ చెప్పండి.
Temperature, ma'am.
Very good. So temperature indicators కావాలి. ఇప్పుడు composition controllers, composition indicators, temperature controllers, temperature indicators. అలాగే కాంపోజిషన్ కంట్రోల్, టెంపరేచర్ కంట్రోల్. అంటే మీరు ఒక ఎక్విప్మెంట్ ఉంటే అనలైజర్, కంట్రోలర్ చేయాలి. ఇంకా నౌ యు నో టెంపరేచర్, కాంపోజిషన్, అండ్ అదర్ వన్ ఇస్ కంట్రోల్. అంటే దాన్ని ఎలా కంట్రోల్ చేయగలం, అంతే కదా. సో సపోజ్ కాంపోజిషన్ ఇస్ దేర్. హౌ యూజువల్లీ కాంపోజిషన్ ఇస్ ఫౌండ్ అవుట్? వాట్ ఆర్ ది మెథడ్స్ ఆఫ్ ఫైండింగ్ అవుట్ ది కాంపోజిషన్? Suppose pig iron అనుకోండి. How do you find out composition of pig iron? What are the methods of analysis? Metallurgical analysis. Or రెండు methods చెప్పండి. What are the metallurgical analysis? The composition.
Proximate analysis.
అది కోల్ కదా బాబు.
Cool.
ఇంకా
Gravimetric, ma'am.
గ్రావిమెట్రిక్, వాల్యూమెట్రిక్. ఇంకా ఇంకోటి ఏంటి? అదే చెప్పండి. ఇప్పుడు గ్రావిమెట్రిక్, వాల్యూమెట్రిక్ వెళ్ళామంటే మనకి గంటలు అయిపోతాయి కదా. మినిట్స్ సెకండ్స్ లో చేసేయాలి. అండ్ ఏం చేయాలి?
Spectroscopy.
అదే, దట్ మీన్స్ వాట్ ఈస్ దట్ యు సే? సో ఇన్స్ట్రుమెంటల్ మెథడ్ ఆఫ్ అనాలిసిస్ అండ్ గ్రావిమెట్రిక్. అంతేనా? రెండేనా? గ్రావిమెట్రిక్ ఆర్ వాల్యూమెట్రిక్ అనాలిసిస్. Other one is instrumental method of analysis. Instrumental method of analysis are fast and quick. So what is that you require? Analysis. So analysis equipment you require. Before analysis of the equipment, I record అవ్వాలి కదా. ఎక్కడో రికార్డ్ అవుతూనే ఆ రీడింగ్ తీసుకోగలరు మీరు, అంతేనా? లేకపోతే మీరైనా రీడింగ్ తీసుకోవాలి. సో వాట్ ఈస్ దట్ యూ రిక్వైర్? టెంపరేచర్ రికార్డర్స్, టెంపరేచర్ అనలైజర్స్, టెంపరేచర్ కంట్రోలర్స్. అలాగే కాంపోజిషన్ రికార్డర్స్, అనలైజర్స్, controllers. So for all of them you require. So similarly slag ఉంది అనుకోండి. slag composition and slag viscosity, slag temperature. Gas బయటకు వచ్చేస్తాం టాప్ నుంచి. From the top you are getting the gas. Gas ఏమేమి కావాలి ప్రాపర్టీస్ మీకు before it goes into the gas cleaning system? What are the required properties you want to know? Gas, BF gas is which is coming out. And composition ఏంటి చెప్పండి?
CO and CO2, ma'am. N and 2.
సో CO by CO2 రేషియో ఎంత? CO by CO2 రేషియో ఎంత ఉంటుంది? CO ఎక్కువ ఉంటుందా, CO2 ఎక్కువ ఉంటుందా?
CO2 ఎక్కువ ఉంటుంది మేడం.
CO2 ఎక్కువ ఉంటుంది.
ఇది CO2 ఏది ఎక్కువ ఉంటుంది? ఫస్ట్ వన్నా, సెకండ్ వన్నా? ఏంటి బాబు?
Second one, madam. Second one.
సెకండ్ వన్. సెకండ్ వన్ ఎక్కువ ఉంటే మరి ఏం చేస్తారు ఆ బ్లాస్ట్ ఫర్నెస్ గ్యాస్ ని? ఆ బ్లాస్ట్ ఫర్నెస్ గ్యాస్ ఏం చేస్తారు? వాట్ ఈస్ ద యూజ్ ఆఫ్ బ్లాస్ట్ ఫర్నెస్ గ్యాస్?
Again send into blast furnace, ma'am, by using tubes and all.
ఆ గ్యాస్ ని బ్లాస్ట్ ఫర్నెస్ ఎలా పాస్ చేస్తాం?
After cleaning it we will pass now.
క్లీన్ చేసిన తర్వాత ఏంటి ఉంటుంది? గ్యాస్ అయితే ఉంటుంది. మళ్ళీ గ్యాస్ ని పాస్ చేసి ఏం చేస్తారు? మీరు అంత CO2 ఉంటే ఆ CO2 ని బ్లాస్ట్ ఫర్నెస్ పాస్ చేసి ఏం చేస్తుంది ఆ CO2? చెప్పండి. If you are telling that after cleaning, if you are passing it into the blast furnace, and you are saying the gas contains more amount of CO2, what it will do when it is passed into the blast furnace?
Can do nothing, ma'am.
So అప్పుడు ఎందుకు పాస్ చేస్తాం? అప్పుడు పాస్ చేస్తే ఎందుకు? Why we are passing it?
See, I think more amount of CO is present.
But in questions are మీ CO కి దిగిపోయారు. ఇప్పుడు చెప్పండి CO what will you do with CO?
That will react with
Oxygen and the CO2 will come.
ఎక్కడ ఉంది ఆక్సిజన్?
No, CO2 heat is used up, ma'am, to heat the air from which is given from the outside.
CO2 ఎక్కడ హీట్ చేస్తుందండి? How will CO2 heat? మరి అదే అందుకుని మీరు అందుకు వినట్లే మీరు ఎవరు.
potential energy.
CO ఎక్కువ ఉంటుంది. ఈ CO/CO2 రేషియో ఎంత ఉంటుంది చెప్పండి?
1, ma'am.
ఇది
1.5 to 2.
గ్రేటర్ దెన్ 1 ఉంటుంది. గ్రేటర్ దెన్ 1 to 1.5 అలాగుంటుంది. 1.2 ఇది ఎక్కువ ఉంటుంది. అన్బర్న్డ్ కార్బన్ మోనాక్సైడ్ ఎక్కువ ఉంటుంది. బట్ ఆ గ్యాస్ బయటకు వచ్చేసే టెంపరేచర్ ఎంత? 100 to 200 కదా. సో మీకు గ్యాస్ కి 2 టెంపరేచర్స్ ఉంటాయి. వాట్ ఆర్ ద టెంపరేచర్? సెన్సిబుల్ హీట్ అండ్ పొటెన్షియల్ హీట్. వింటున్నారా అందరూ? మళ్ళీ చెప్తున్నాను, చాలాసార్లు రిపీట్ చేస్తున్నాను. సో బ్లాస్ట్ ఫర్నెస్ గ్యాస్ has got more amount of CO, less amount of carbon dioxide, because carbon dioxide again will react with the C and give 2 CO. That 2 CO is reacting, you are getting it. This carbon gas which is coming out from the blast furnace, the temperature is 100 to 200. You have, if it is a gas has 2 temperatures. One is a sensible heat, the other one is potential heat. Suppose I say this is the gas. దీని టెంపరేచర్ 100 అనుకోండి. ఈ గ్యాస్ టెంపరేచర్ 100 డిగ్రీ. దిస్ ఇస్ అ సెన్సిబుల్ హీట్. మీరు దీనికి ప్లస్ సమ్ హీట్ చేస్తే ఈ CO2 విల్ బర్న్ టు CO2. ఈ హీట్ ఇచ్చేది పొటెన్షియల్ హీట్. సో ఓకే, సో ద గ్యాస్ హెస్ సెన్సిబుల్ హీట్, దట్ ఈస్ అ ఫిజికల్ హీట్. If you burn the unburned carbon monoxide, it will give carbon dioxide. Heat is produced. So that heat is known as a potential heat. You are understanding? So C plus O is equal to CO. It is incomplete combustion. It is incomplete combustion. C plus O is equal to CO2, it is complete combustion. So, this unburnt CO, if it burns to CO2, complete combustion. So, this gas goes to the gas cleaning system, dust catcher, then scrubber water is sprayed. So, 100 degrees for room temperature. Electrostatic precipitator, water is also coming in contact. So, 100 degrees, you are not able to maintain. It comes to room temperature. So, you are not recovering the sensible heat or the physical heat. This gas is taken to the blast furnace stove, where again air, with the help of a burner, you are burning the carbon monoxide to carbon dioxide. That heat is coming out. The carbon dioxide heats the refractories and is let off into the atmosphere. Then cold air is passed. It takes the heat of the refractory bricks and the hot air is passed into the blast furnace. Always remember, hot air is passed into the blast furnace because air supplies the oxygen for combustion of the coal. So these are the operations in the blast furnace. Last class I was telling you. So blast furnace operation consists of blowing in operation, banking, blowing out, tapping, fanning. Blowing in consists of drying, followed by filling, and then lightning, and operating until the routine practice is established. So the process of starting a newly lined blast furnace is known as blowing in operation. Standard procedure is not that, depends upon the local conditions. Drying means removal of moisture in a newly lined blast furnace. We dry the blast furnace by supply of hot blast from the stove or use of a Dutch oven as an auxiliary furnace to generate and supply hot gases to dry the furnace, or use of wood or coke fire in the hearth. So you can also dry the furnace lining. After drying, what is that? We have to fill it with the raw material. So at the end of drying, depending upon the method used for drying, the furnace is cleared of its things used for firing. Suppose you are using wood or fire. After firing, ash will remain, the impurities will remain. So depending upon the method of drying, the incombustible matter, etc., which is there, is removed. Then the coolers are turned on. Once the temperature is tolerable, furnace personnel will get into and prepare for the filling of the lining. So while filling, a checklist is prepared. Depending upon the checklist, they go step by step. So after filling, operating is done, normal operation. So after filling the furnace, the bells are opened and the dust catcher dump valve is closed. What will happen if you close the dust catcher dump valve and the bells are open? The gases will go away into the atmosphere. It is when you close the dust catcher dump valve, the gas is not allowed into the gas cleaning system. It is let off into the atmosphere in the beginning. The air in the dust catcher is purged out with full head of steam. The furnace is lighted either by inserting red hot iron bars through the tubes or by using gas torches. In the very beginning, coke fire is yet to be developed. So in igniting, they use red hot iron bars through the tubes. The tubes are opened for inserting of red hot iron bars to initially start a newly lined blast furnace. A newly lined blast furnace is started, filled, fired, dried, then filling, then it is lighted by inserting the red hot iron bars or using gas torches. This is how the lighting of the furnace is done to start the process. So once lighting is done, combustion will take place, then the raw materials are charged. After lighting, burning is allowed with natural draft. That means blast is not put up for 24 hours. Slowly a light blast is put on. Complete blast will be put on within a week. That means what? Whenever we are going for a blast furnace operation, initially the air is not charged. It is the natural air is going into the furnace for about 1 day to 2 days. Then slowly a light blast is put on. Within a week, the full blast up to its rated capacity is taken into the blast furnace. So bells are closed, whereas good amount of gases emerge from the top. Dust catcher dump valve is open, so the gases will go into the gas cleaning system. Tap valves are still open to allow the hot gases to come out. When there is a decrease in amount of the gases, it indicates the slag formation. Then the tap holes are closed. Then the normal furnace lighting, furnace operation is continued. Till here, we will stop it here. So this is the starting of a newly lined blast furnace. That is, it consists of what? Newly lined blast furnace, blowing in. Blowing in is newly lined furnace, drying, filling with raw material, operation until routine practice is put on. Until means what? In the very beginning, we cannot estimate at what time the slag is forming, at what time reduction is taking. Usually, iron ore reduction complete will take place within 6 to 8 hours. So by trial and error, they will know at what time when they charge, at what time the slag has to be tapped, the hot metal has to be tapped. Once it is in routine practice, they can put the blast furnace under automatic control. That is the starting of a newly lined blast furnace. And in the beginning, blast is put on slowly, natural draft, then slowly with natural draft, then with full blast. In the beginning, the gases are let off. After some time, then only the gases are let into the gas cleaning system. We will continue these operations in the next class. Tomorrow is a holiday, so next week we will continue. I think you know from next week onwards, as per timetable, as per credits, the classwork will be there. That means weekly 4 hours class will be there. for all of you. Do you know that?
Yes, ma'am.
Oh. You are able to understand what I am telling?
Yes, ma'am.
Yes, ma'am.
మరి మీరు ఇంకా బ్లాస్ట్ ఫర్నెస్ గ్యాస్ స్టవ్ ఎన్నిసార్లు చెప్పినా స్టక్ అప్ అక్కడే. ఓకే, థ్యాంక్ యూ.
Thank you.
Ma'am, can you share this PPT, ma'am, the present PPT to us? So that we can...
ఇంకా నవ్వలేదు మరి. ఇంకా వాట్ ఆర్ ద స్టెప్స్? బ్లోయింగ్ ఇన్, బ్లోయింగ్ అవుట్, ట్యాపింగ్, బ్యాక్ డ్రాటింగ్, ఫ్యానింగ్. ఆ స్టెప్స్ అన్న ఇంకా మీకు షేర్ చేస్తాను. ఈ లోపల ఇఫ్ ఆల్ ఆఫ్ యూ ఆర్ దేర్, ఐ థింక్ ఓన్లీ 44 people, వెంటనే వదిలేస్తారు క్లాస్. వదిలేస్తారు, వెళ్ళిపోతున్నారు. యూ టెల్ యువర్ క్లాస్మేట్స్ that you study the first PPT, all of you go to the PPT. I think what we will do is next class, because already 4 hours start out on that, I want to know how much you have read for the first PPT. So PPT ni nenu repu message pedtanu. I will divide the number of PPTs into batches. I will divide you people into 10 people, one batch. You present those PPTs and you explain in the next class. Is it okay? Hello?
Okay, yes,
I will give you in detail. మీకు PPTs కూడా ఇచ్చేసాను కదా, మీకు 10 groups ని డివైడ్ చేసి ఏది చెప్పాలో కూడా మీకు చెప్పి మీకు మెసేజ్ పెడతాను. ఆ PPT మీరు షేర్ చేసి మీరు ఎక్స్ప్లెయిన్ చేస్తే ఒకటి జస్ట్ రివ్యూ లాగా ఉంటుంది. బికాజ్ లాట్ ఆఫ్ టైమ్ ఇస్ దేర్ ఆల్సో. If you have no objection to this, we will go like that. So that I will also understand, you will also understand. You will also share the PPT చదివినట్లు ఉంటుంది. ఎందుకంటే మీరు చదవట్లేదు PPT. ఈ రోజుకి మీరు బ్లాస్ట్ ఫర్నెస్ గ్యాస్ గురించి ఇంత తప్పు చెప్పడం నాకు చాలా బాధగా ఉంది. ఓకే, థ్యాంక్ యూ.
Yeah, thank you, ma'am.
ఓకే.